Hello, my name is Brandon McKenzie and welcome back to another lesson in your optics video set. In this lesson, we'll be building off the previous one, which covered converging systems, by introducing diverging systems. Conceptually, I would like you to think of diverging systems as the opposite of converging systems. So with that said, let's jump into our first learning objective, identifying a diverging system. Now, to be able to identify a diverging system, we have to begin with the definition itself. So that's what this first bullet point is. Now, if this is the first time you've seen this definition, it can come up a little complex, so let's greatly simplify this. First, let's start off with the term diverging. Simply put, a diverging system is one that diverges light. Go figure. Simply put, a diverging system spreads out light. Now, speaking of the word system, let's explore that. A system in the scope of optics refers to either a lens or a mirror. And it's very important that you are able to differentiate between these two kinds of systems. In fact, it's so important that we will go through two examples of a diverging system, one for mirrors and then one for lenses. Now, I always say the best way to look at a diverging system is to literally see it, so that's what we're going to do. Now, here we're dealing with a diverging mirror, and we can validate that it's a mirror because in the diagram there is one curved edge and one straight edge. And when the incident rays of light hit this mirror, we can see that they begin to spread out. Thus, it's a diverging mirror. The more complex portion of this definition is the part that reads, light rays spread out as they move away from the focal point. So let's explore this a bit. So let's start by looking at the location of the focal point. We can see here that it is located behind the mirror itself. So when the light rays are reflected and moving away from the mirror, they also move away from the focal point. Now, this is actually a great way to remember that diverging mirrors' focal points are located behind the mirror itself. Because if you just remember light rays diverge away from the focal point, then you're all set. Now that we understand diverging mirrors, let's take a look at our second system, diverging lenses. Now, the biggest difference between a lens and a mirror is that while a mirror will reflect light, a lens will refract it. In other words, instead of light bouncing off a mirror, it will bend when it hits a lens. Again, the best way to look at this material is to see it, so let's pull up a diagram here and work through it. Here we have a diverging lens, and we can verify it's a lens because both sides of this object are curved. And because it's a diverging lens, we do suspect that when the incident rays come in, they will spread out. Now let's focus on this focal point. We can see here that it's located on the same side as the incident rays of light, so therefore we could also say it's located in front of the lens. And let's reconcile this fact with our general definition of diverging systems. Recall that light rays tend to spread out as they move away from the focal point. Let's see if that's true in our diagram. And yes, as the rays of light refract and move away, they do spread out. Now that we understand how light reflects and refracts in diverging systems, let's take a moment to discuss some more subtle parts of these two ray diagrams here. First, notice that for diverging lenses, there's actually two focal points, one on each side. Now I know what you're thinking, but wait, didn't we just establish on the previous slide that focal points are on the same side as the incident rays? Yes, that's still true, but remember, lenses can encounter light from both sides. So on this image here, we see the light is entering the lens from the left-hand side, therefore the focal point is on the left-hand side. Now let's switch this around. If we had incident rays coming from the right-hand side, you guessed it, the focal point would be on the right-hand side as well. So for that reason, we show the focal point on both sides of diverging lenses. Now at this point, you've been looking at these ray diagrams for quite some time, and you might be thinking to yourself, well, why does a diverging lens diverge light? And why does a diverging mirror diverge light? Well, the answer comes down ultimately to the shape of the lens or the mirror. Diverging lenses are concave, while diverging mirrors are convex. Now you do want to memorize and understand this, but there is a very, very useful mnemonic to help you do just that. The term concave, I want you to focus on that second part of the word, cave, and think of, well, a cavity or a cave. Because the surface of the mirror or lens would actually look just like a cave. In fact, I could even draw a little guy in here being inside a cave. Just to remember to always look at the side where the incident rays of light are coming. Now for the term convex, simply just focus on convex being the opposite of concave. So that would mean that there is a protrusion outwards in the direction towards the incident rays of light. And with that said, I think we're ready to apply this content and answer some questions. First, which of these following ray diagrams correctly depicts a diverging lens? At a glance here, we can see that both images are showing us the ray diagram. So this could be pretty straightforward. For the left diagram, we can see that the lens will converge light towards the focal point. For the right-hand diagram, we can see that the rays of light diverge away from the focal point. So now all we have to do is just recall which one spreads out light, and it could be fairly obvious here that the right-hand image will be spreading out or diverging the light. Let's try another one. This one could be a bit tougher because we no longer have the ray diagrams to help us out. Now, of course, it is within your skill set now to simply draw out the ray diagrams, but you shouldn't have to. The reason why we emphasize learning the shapes of a diverging mirror and of a diverging lens is so that at a glance, you'd be able to tell us whether or not a lens or a mirror is diverging or converging. So looking at the left-hand image here, we can see that the center of this mirror is thicker while the tops and the bottoms are thinner. Therefore, this would be a convex mirror. Right-hand side, we see a narrow or a thin center of the mirror and thicker tops and bottoms. Thus, this will be a concave mirror. Remember, you can draw a little guy in there and he's in a cave. Now we just have to recall which one of these mirrors diverge light, and recall that the convex mirror is the one that diverges light, meaning this image here is the diverging mirror. So now, not only should you be able to relate the shape of a mirror or a lens to its behavior, either converging or diverging a ray of light, you should also be able to answer questions about the location of the lens's or mirror's focal points.